So from a terminal performance standpoint, all bullets are based on velocity. They're designed to work within a certain velocity range, and the bottom end of that range, the low velocity window, dictates, where expansion's going to stop occurring. If you go below that lower velocity, the bullet's not going to work as intended.
All right, what is up, everybody? I have my good friend to my right, Mr. Ryan Muckenhirn. Ryan, you're generally across from us.
I know, this is an honor.
Yeah,
doubly.
Bestowing us with information, but we've got somebody else to do that today. We've got Jayden Quinlan, Ballistician from Hornady, special guest, going to chat with us today on a topic that I know you and I are very curious about.
Yes.
I think we have some base knowledge there, but I think we're about to get a lot more knowledge. We're going to talk today about bullets and terminal performance. So essentially, what's happening to that animal, when it's hit by a bullet? How is that bullet, killing the animal? And then that should shed some light on kind of like bullet selection and kind of like lead us into talking about bullets.
Yeah.
Does that make sense? Jaden, how did I do there? I'm going to ask you. You're the ballistician.
Fantastic, Mark. I couldn't have done it better myself. This thing's pretty... You wrapped it up. We're done here, right?
Yeah. Let's go have a cold one. But Jaden, before we get too deep, we've known each other for a lot of years. Seen each other at a few shooting competitions. That you're a pretty darn good shooter, actually. But maybe tell us a little bit about yourself, a little bit of background, how you ended up at Hornady, and a little bit about what you do there. Which I know that's like telling you to hey, how about your life story in 30 seconds? But we'll give her a go anyway.
Yeah, let's try it. I grew up in southern Colorado on a farm and ranch out in the middle of nowhere, 30 miles from the nearest town. So I didn't realize that private land existed, that you couldn't just go do whatever you wanted on until I was much older in life, so about as free as you could get. That's where I fell in love with shooting and ultimately ballistics. As many in the U.S., as a kid on the farm, you're given a .22 and go get after the coyotes and the prairie dogs, I had a .22 Magnum, so the cost of ammunition for me was way more expensive than like my two cousins I grew up with that had .22 long rifle. So I had to be a little bit more choosy on my shots. It was a lot more expensive to shoot. So that led into trying to figure out how to be better, which you could tie that right into ballistics, right? I mean, the more you know about that, the better off you are. So I really fell in love with ballistics back then. Kind of studied it as much as I could myself through whatever materials I could get my hands on. Back in that time, pre-internet days, you were kind of limited. So did that, fell in love with ballistics, did a stint in the military. That love of ballistics continued. Met the right people at the right time who made some phone calls on my behalf. Got some articles published as a writer that got me a little bit of not notoriety, but maybe attention from some of those movers and shakers in the industry. They made phone calls on my behalf and said, hey, we got a guy here that you guys should look at. Went around to different interviews, and my last interview was Hornady. I had the other interviews were kind of like, hey, you going to take the job or not? I said, well, I got one more to do, Last stop was Hornady, and as soon as I finished that interview, I knew this is where I should be. Been here for 10 years now, and as a ballistician, I get to do probably the coolest stuff around here. I mean, research and development, if it's a new projectile design, I get to work with the team that does that. New cartridge design for ammunition, I'm part of the team that gets to do that. And all facets of ballistics, internal, external, and terminal ballistics. I mean, I get my hand in all of it. So it's from a kid that fell in love with it long ago to the grown adult that's doing it as a career now. It's pretty cool to have that connection.
That is awesome. Like you said, it sounds like you have your hands in all the different really cool, fun pots of the organization there.
Absolutely, yeah. I'm very fortunate.
What about how many rounds do you fire in a year?
Oh, man.
Baseline, approximate.
Like personal and work-wise?
Sure.
Tens of thousands, probably. It's hard to make a number. I mean, there's days where we'll be doing, say, a function test where I'm looking for something particular, and we'll shoot thousands of rounds in a single day. There's other days where I don't shoot a single round. I might be doing computer analysis stuff or whatever. But I would say somewhere in the order of tens of thousands. I don't know how many tens, but a lot. Yeah.
Lots of firsthand practical experience there.
Yes.
What about so let's start here. Let's talk about, we're kind of going to, in some ways, go in reverse. But, I think we're going to think of this podcast, I guess, like I said, in some ways, like, from maybe a hunting bullet perspective, right? When a bullet hits an animal, what's happening? And I guess ideally, like, what do you want to happen?
Absolutely. So first, we need to figure, what is our goal? Our goal in hunting is to kill the animal cleanly and efficiently and quickly, right? That's our job as the hunter. So how do you kill the animal? You deprive the brain of oxygenated blood supply. That's what causes cellular death, right? And ultimately, the cellular death is the result of ultimate death. That's kind of we'll start there and work our way back. So to cause that death, we need to stop oxygenated blood supply to the brain. The first thing that causes is unconsciousness, and then if that unconscious or lack of blood supply to the brain continues, it will be cellular death, and you will die, right? Now, there's a couple different ways to do that. The body's made up of a couple different systems. So you have the circulatory system, so that is your veins, your arteries, your heart, the blood, right? So you could think of that as like a pump system with pressure, right? Like in your house, kind of same thing. You got pipes, you have a pump, which is the heart, and it builds pressure, and it sends all that oxygenated blood all around the body to keep the cells alive, right? So that's the circulatory system. Then you have the respiratory system. That's your airway, your lungs, your diaphragm. It brings that oxygenated air in. The exchange of the oxygen happens in the lungs between the air and the blood. So that's how it gets oxygenated. So the respiratory system is kind of like the ventilation system in your house, or the HVAC, right? We could think of it that way. And then the third system is the nervous system. So that's the electrical system. That's what keeps all the electricity going to the pump, to the heart, to keep it beating and pumping, the lungs breathing, all that's controlled by that. So you could kind of think of this in the form of your house and the systems that you have in there. Now, when we're hunting, we're generally trying to affect two of those systems at the same time because of the proximity that they are to each other. So we're going after the circulatory system and the respiratory system. And the reason we're doing that is because that vital area that we talk about in animals contains the heart and the lungs. The lungs are kind of wrapped around the heart. So you have one target area that contains two of those systems. Now, there's different timelines associated with affecting those systems. So the fastest system to affect is the nervous system. So that would be like a spinal shot, right? So if we've ever shot an animal and it's a spinal shot, usually it's an immediate response. The animal just drops. Its legs come out from under it, it's down, and it's done. It's not necessarily dead at that point, although it looks that way, right? From the response of the animal, it's just down and it stopped moving, and we kind of associate that with death. But death is going to come a little bit later because you still have that oxygenated blood supply in the body that's keeping the brain alive for a certain amount of time. But death will come very quickly after that, because the heart has stopped pumping because there's no electricity going to it anymore, so that oxygenated blood isn't traveling. So the fastest one is that nervous system, but we don't generally target that for hunting. Some hunters do. They might try to take a neck shot or something if they're trying to preserve meat. They don't want to deal with bone fragment or anything that may happen, on that front shoulder, that front quarter, if they miss the vital areas just a little bit. So that is an applicable target area for some hunters, but the majority of us go for that traditional vital zone. So the next fastest time to death is the circulatory system. So if we can hit the pump, if we can hit the heart, there's an immediate drop in pressure in that water pipe system, right? So now that pressure has dropped, you still have some residual oxygen at the cellular level, just due to the flow that was there before you dropped the pressure, but you have unconsciousness and death very rapidly after that. The longest one is going to be the respiratory system. If the only thing you affect is the ability to get that oxygenated air in, that takes quite a bit longer. So essentially you poke a hole in a lung, or both lungs, those lungs are still functioning. They're still exchanging oxygen with every breath that's occurring, but there's a leak there. So eventually that leak is going to cause a tension pneumothorax. That pressure in the chest cavity is going to be greater on the outside of the lung than it is on the inside of the lung. You get collapsed lungs, and then you have death. But that's a pretty long timeline. You're talking minutes, hours, days maybe, where if you affect that circulatory system, you're talking seconds, minutes till death. So that's an important concept to understand, because when we ultimately get to talking about bullets here and what different bullets do and they're intended to do, there's a lot of judgment calls that are made about bullets based on our experience in the field as a hunter. So if I take the exact same setup, system, conditions of the shot, everything's identical, and I shoot an animal this 1 year, and that animal, drops in. It's a good vital shot right into that heart and lungs. I shoot that animal, make a really good shot, and that animal, kind of drops in its tracks, and as I walk up there, it's dead and it's done. Easy, perfect hunt, right? Exact same circumstance. The next year, I shoot an animal at the same range. Everything's identical, and that one runs 100 yards before it falls over dead. A lot of people will say, "Oh, there's something wrong with that second setup. That bullet failed or something happened," right? When in reality, it may not have, they're all exactly the same, but what you did is you had different timelines associated with death. It may have been that first animal was very relaxed. It wasn't in a heightened state of alert, kind of its predisposition resulted in it just dropping in its tracks and unconsciousness, death really rapidly. That second animal might have, just heard a coyote run by behind it or whatever, and it's kind of ready for that fight or flight deal. So as soon as that bullet hits it, its response is to go. Although the workings of the bullet were identical, our perception to that is that there was something wrong with this bullet because the animal ran 100 yards and the other one didn't. So this bullet's better than that. A lot of people make those assumptions without knowing about those systems that you're trying to affect and the timelines associated with death that come with them. But it's really important to understand that before you go into talking about specific bullets and what they're intended to do and designed to do, because you can't fully appreciate that without understanding that little piece. Now, if I can, before we go into bullets, there's one more thing we should cover, and that is starting to lead into probably what we'll get into with different types of bullets and what they're for. This is how the bullet works from a penetration, expansion, energy, kind of those different metrics that we like to talk about. So if we're going to go for that vital shot, the most important metric we can have is shot placement. So I can have the best terminal performance bullet in the world that has more energy than anything out there, with a cartridge that's pushing it at the craziest velocities you've ever heard of. You've maxed out all your categories, right? If you hit that animal in the hoof, none of that matters. Why? Because your shot placement's bad, right? If you hit that animal in the hoof, you're not affecting any of the systems. You're not going to shut the lights off on the nervous system. You're not going to shut the pump down with the circulatory system, and you're not going to cause a big leak in the respiratory system. That animal's not going to die, right? Now you could argue that, you might have some damage to some veins or arteries from that, and eventually you get death, but that's not what we're looking for on that clean, ethical kill. So the point is, shot placement is the king. You need to put that bullet in the spot where it needs to do its work, okay? So shot placement is most important. Next most important is penetration. So an example of this would be if I pick the wrong bullet, one that, let's say, is designed for varmints, something that's going to expand very rapidly, it's not going to penetrate very deep because it's not designed to. If I use that varmint bullet on a bull elk and my shot placement is absolutely perfect, it's not going to matter because I didn't get deep enough to affect those vitals, right? I didn't get to the heart and lungs. So penetration is number 2 of importance. Number 3 is expansion, because what expansion does is that allows us the energy that bullet has when it impacts the animal. The expansion allows us to dissipate that energy more rapidly into the animal, which is our goal. So those things are in a tiered approach for that specific reason. And we should probably touch on energy a little bit here, because that's a common metric that people hang a lot of weight on. And energy is an important metric, but it's not everything. There's some caveats. When it comes to energy, like I said, the goal is to deposit that energy into the animal and cause terminal damage to ultimately cause a clean, efficient kill. What matters is how that energy is deposited. because I can have a bullet that's extremely heavy and going extremely fast. It's going to have a lot of energy. But if I don't deposit that energy into the animal, let's say it's an FMJ, full metal jacket, or a bowtail hollow point, or one of these bullet designs that's not meant to expand at all, it doesn't deform, that bullet's going to zip on through. It's going to essentially create a little ice pick hole all the way through the animal. It really didn't transmit much energy into that animal. And so that having energy is good, but how it's deposited is equally as important as how much energy you have. So kind of with some of those ground level concepts covered, we can probably go into the detailed questions about different bullet designs and stuff and how they play into those things that we just talked about.
Absolutely. That was a phenomenal explanation, by the way. No, that was perfect. And I think everything you brought up is super important, sets a solid baseline for all the different things. So we've talked about, like you said, that terminal performance, what's happening, what needs to happen, a little bit how that's happening. So you guys make a ton of different bullets, and bullets designed for different applications, right? You talked about even varmint bullets designed for varmint hunting, not for big game hunting. So within the context of big game hunting, you guys also have several different styles of bullets designed to kind of perform differently, potentially under different conditions, different size game, maybe different average shot distances. But talking about the bullet, you have different shapes. Everything. What are the most common, even just bullet materials? Let's talk about bullets here. What's a bullet made out of? And I'm sure there's lots of differences with that as well.
So generally you have two types of bullets. You would have a monolithic style and a cup and core style. So the monolithic style just means that bullet is made of one monolithic or single material. And that material is generally a copper or a gilding metal type of material. The cup and core bullet is made of that copper or gilding metal jacket on the outside. So that's what you see when you pick up a loaded round of ammunition or a bullet itself. That's what you see on the outside is the jacket. What's on the inside of that is a lead core. And that lead core, there's different types of antimony that's used, and so that's just how hard the lead is, essentially, how malleable it is, how much it wants to move. And we vary that depending on the application. Like you said, we make a bunch of different bullets for different jobs. Depending on the job will dictate how the jacket is designed and laid out, and the lead as well. So, but from a basic level, you have the monolithic style and the cup and core style. Okay,
gotcha. And then with that, you're talking about different, how the jacket works. So how maybe contrast a couple different, jacket styles.
It really depends on what the application of the bullet is. So we talked about varmint bullets a little bit. Our VMAX line is a very thin jacketed bullet because the more thin that jacket is, so the jacket is going to be harder than the lead. So if you were to try to take a bullet that's formed into just a cup, it hasn't been swedged up into an ogive or a nose yet. It's just kind of you can think of it as a cup of water, but it's a cup of copper, right? If you took that and you tried to peel that copper jacket open, it's pretty hard to do. If you took the lead core that's inside of it and you just push down on it, it's going to be a lot easier to mush it. That lead is softer than the copper. So the way the jacket is designed really plays into how fast how fast or slow the bullet's going to expand or open. So with a varmint bullet, generally you're going to see thinner jackets because we want them to open really rapidly. You're hitting let's say a prairie dog that's 3 or 4 inches thick. You want that bullet to go from the normal state of the bullet that you see it visually, when you look at one, to a completely expanded, dissipated energy within 3 or 4 inches. That thing needs to be very soft and thin for the jacket. You can contrast that with a heavy jacketed hunting bullet that's designed, say, for big game hunting like elk, where I want that thing to start to expand and open in a controlled way over 2 or 3 feet. So that jacket design is really critical for that.
Ryan, you had something?
Yeah, throughout the years, I've seen a lot of terminology, marketing monikers or names or whatever associated with bullets, but I basically look at them like the thin tapered jacket like a varmint bullet would have on your VMAX, or something like an interbond or an interlock. And a lot of people see bond and lock and don't necessarily understand the difference between the two projectiles and like how that core is adhered to the jacket, either mechanically or chemically. If you jump into that a little bit, like what is an interbond bullet? What is an interlock bullet?
Sure,
or a bonded
great question.
bullet or a locked or partitioned bullet of some kind?
Yeah. So we'll back up just for a second, that monolithic versus cup and core.
Yeah.
Monolithic is kind of monolithic. That's just what it is. Within cup and core, you have a bunch of different kind of families of bullets that all fall under that cup and core definition. So that would be your question. What's the difference between a bonded bullet and a interlock or mechanically bonded bullet? So traditionally, the term bonded bullet is a chemical bonding between the core and the jacket. Now, the purpose of bonding is because as that bullet expands, if the core and the jacket separate from each other, the core comes out of the jacket, now you've taken the energy that bullet had all as one piece and you've divided it out into two separate pieces that you split the weight of them, you're not going to get the penetration depth. So generally what's called a jacket core separation, when the core comes out of the jacket during expansion, that's not a good thing because now you've reduced your penetration depth because you've taken that one thing that weighed 200 grains and now you've split it into two pieces, and the jacket piece probably weighs 50 grains and the core piece weighs 150 grains, and they're now two different things. It's not going to penetrate as deep as you want, say to get to the vitals like we talked about at the start. So when you bond it, your goal is to keep the jacket and the core together no matter what happens, no matter what it hits, bone, whatever. So with the chemical bonding, you essentially weld the jacket and core together through a chemical process. Now, one of the downsides that you see with that is you have to heat that bullet up when you make it, and you can only make it with pure lead. So pure lead is soft, and then as you get into the higher antimonies, it becomes harder. So to be able to chemically bond, you have to use pure lead, which means the bullet's already soft. So you lost one ability to control the bullet's expansion with the hardness of the core that you choose to use because you're forced to use pure. So now that bullet's softer, although it holds together really well, generally those bullets aren't quite as accurate as a traditional drawn cup and core bullet. And that's because you can't control that core as well because you're heating it up and you're welding it to the jacket. And so a lot of times a traditional bonded bullet may not shoot as well as, say, a cup and core style bullet of equal design. And that's the reason for that. So although the bonded bullets are great for jacket core separation, they don't fail, right, because they're welded together. There's some trade-offs that come with that, and those trade-offs are generally in accuracy and bullet softness. Now, there's other types of bonding. There's mechanical bonding, which is what we have in like the Interlock or the Spire Point series. So that's that traditional old lead-tipped hunting bullet that you've seen used for decades now, tried and true, right? That's a mechanical interlock. So what that is we take a piece of the jacket and we crimp it into the core. And so now the core can't come out because there's a piece of jacket, biting into the core to prevent it. So now you get the benefit of, I don't have to worry about that soft lead, the issues that come with making a bonded bullet shoot really well because I'm doing a traditional cup and core where I'm inserting the core into the bullet. I'm hitting it with a punch in a very controlled manner to make the core fill out into the inside of the jacket. It's much easier to make an accurate bullet that way. So that would be a basic understanding of the difference between a traditional bonded and a mechanically bonded bullet with the cup and core design.
With the monolithic style, you don't have that lead to expand. How is that bullet working?
So the monolithic, being that it's made out of essentially the same material that your bullet jacket is, and I just got done saying that we control the thickness and all that of the bullet jacket to control the expansion. Well, you kind of go the opposite way with the monolithic bullets. You have to thin that out so much because that material is so hard. In that same example I gave of trying to, open up a copper cup, that bullet is so hard, you're thinning it out in a way that it weakens it so that it will open. And so that's kind of it's a different methodology than the cup and core. The cup and core, we're using the jacket to slow down the expansion. With the monolithic, we're we're taking it away to make it expand at all. Because if you made a solid bullet, which you'll see sometimes, like a solid lathe turned bullet, so that's a homogeneous piece of material that they just turn the bullet shape on a lathe, like that thing's solid on the inside. Those will not expand at all, ever. I mean, if you hit a piece of steel, it might deform it a little bit, but traditional expansion would be an increase in diameter in a controlled way. It kind of looks like a mushroom when it's done. That would be considered controlled expansion. Those solid coppers, you can't do that because that material is so hard.
And sometimes that would be advantageous too. I mean, if we were like looking at a dangerous game application where the objective was penetration and like skeletal structure breakdown, you'd enter a solid of some kind.
Yes,
generally huge. Like huge calibers, 458 lot, 500 Jeffrey, 505. Gibbs,
exactly.
Like
a lot of the big five, the dangerous game species in Africa. That's what you're looking for. On a Cape Buffalo, you have to have that penetration. It's absolutely critical. So a lot of those bullets are of that design. We do a copper-clad steel jacket for those that have a lead core, because the other trade-off that you have with those monolithic designs is you don't have any lead to make them heavy. They're just that lighter weight copper gilding metal material. Well, weight is one of the parts of getting penetration and also energy, right? The sectional density, which is really tied to penetration, comes from that bullet weight. So the heavier that thing is, the deeper it's going to penetrate, all other things being equal.
Gotcha. It's interesting, circling back to, when we were first got in this conversation talking about how that bullet performs, and you're talking about like a varmint bullet versus like, maybe something for deer, and like what it takes to kill that animal. It's like, well, you don't want that rapid expansion on the deer like you would for the varmint, and it's almost like a step up when you're talking about the deer versus the Cape Buffalo. It's like a similar relationship of what you need to ultimately kill that animal, quickly and ethically, and it's like, for that, might want to go with a solid.
Yeah.
Mm-hmm. Yep, that's a great way to look at it, Mark. That's correct.
What about Ryan? Did you have something? You look like you had
No,
something.
I have got like a million questions because I'm sitting across from like one of the world's best ballisticians, so I'm like super excited and trying to contain myself.
Well, before I go, Ryan, why don't you fire away?
Well, I'm curious, and I don't know if I'm going to get, I guess, out of order in the sequence of things, but like as long as I've been in the industry, I've seen at least the American shooter changing mentality on bullets, like what is important. And I can remember when energy was king, and everybody was on that, and it was all about, we didn't want any bullet to exit a creature because that wasn't good. That was deemed a failure because it didn't deposit all that energy. But there was a whole bunch left on the table from like, how well did that bullet hold together? What did it look like when it was getting to the good stuff, if it got to the good stuff? Why is an exit a negative, or why was it a negative? But I imagine in your position, there's a lot of challenges trying to meet the perceptions or the expectations of the shooter. Like I see people gravitating towards very high ballistic coefficients and deeming some bullets inadequate because they have a poor BC, even though the bullet that they need is one that actually doesn't have a good BC. It's built a different way. It's supposed to do something differently. How do you navigate that when you guys are looking at this? Like how do we optimize that bullet while still meeting that customer's expectation or perception of what makes a really good bullet?
Great question. I think the best way to answer this is maybe to look at the evolution of hunting bullets a little bit. Yep. I think that'll answer it. So if we go back, 40s, 50s, 60s time frame, hunting bullets of that era are the old traditional spire point design. So that's usually a flat base bullet. In later years, you saw the adoption of the boat tail design, but you have a pretty basic flat base bullet with a lead cap sticking out the top of it. And the purpose of that is that when that bullet hits an animal, that lead cap is the same lead that's down inside the bullet. And lead is soft, so when it hits the animal, that lead is going to deform and mushroom. And as it does that on the tip, it kind of takes the very tip of that jacket, the jacket edge, and forces it open as you're building that pressure on the lead being driven into the target media. It pushes that jacket open, and you get traditional expansion. So that's the old method of doing that. As you saw the advancement of manufacturing technology on all fronts, you guys included, optics, barrels, our ability to make bullets, right? As our machinery and our measurement instrumentation became better and better and better over those decades that passed, from the 40s, 50s, 60s, you saw improvements in all those fields. So what does that mean? It means that the user now has equipment that allows him to start stretching limitations. Generally, those limitations are from a range perspective. So that traditional hunting of the 40s and 50s and 60s era was probably, with the legacy cartridges, it was conducted at, 1, 2, maybe 300 yards. I mean, if you shot a deer in 1955 at 300 yards, you were the talk of the town, right? Yeah. Because that was pushing the limits of what was normal. Well, as all of that equipment gets better, the average shooter or hunter has access to better equipment. That means that he can start to take his capabilities that used to be limited to 200 yards, and he can take them to 300 or 400. And so you saw that in the 70s, 80s, 90s, right? That's where you see that old spire point design evolve into the SST, which it has it incorporates that polymer tip, right? So what that did is it made the nose of the bullet longer, and when you do that, you increase the aerodynamic efficiency, or the BC would be the common term. So you make the BC higher. Well, what does that do? Well, it means that I retain velocity better. So from a terminal performance standpoint, all bullets are based on velocity. They're designed to work within a certain velocity range, and the bottom end of that range, the low velocity window, dictates where expansion's going to stop occurring. If you go below that lower velocity, the bullet's not going to work as intended. So as we get more efficient aerodynamically, that means that our bullets work over longer distances. They expand like we want them to over longer distances. So you see that into the SST design, and then into the GMX design, or now the CX, right, with the changes we've made there. But the legacy product would be the GMX or the Barnes X. You see these monolithic designs that are out there. That kind of gave you that same increase in aerodynamics that you see with the tip and the longer ogives and the better shapes and stuff like that to maintain that velocity. As that progresses, what you saw start to happen was really the long-range craze that hit in, say, the early 2000s. And the way I view that is that information existed before, the long-range information, if you want to put it into a umbrella term. But it was primarily in certain communities, the military sniper communities, maybe the law enforcement sniper or sharpshooter communities. They kind of had an embargo on that information. You could find some books out there and figure it out back in the day, let's say the 80s or the 90s, on your own. You had bench rest guys. Obviously competitive shooting was there and happening at long range, but not in a field sort of environment where you're what we see now, where you're unknown target distances, you're making compensations on the fly, you're doing all that. That wasn't the case back in the 80s and 90s. Then comes the internet, right? Now everybody has access to everybody's information. So what you saw was that embargoed information that was primarily held by the military and law enforcement communities on how to do field long-range shooting now became accessible to every man. And so now what we've seen is the long-range craze, right? You guys have seen it on the products on your end. We obviously have seen it on our end. And you can take a guy now that can watch an hour worth of YouTube videos or spend 30 minutes with his buddy that knows how to do it, transfer that information to that guy. You guys did a video on it. You can go buy, a $400 rifle, slap a $500 scope on it, and hit it 1,000 yards. That I thought that video was really cool because it encompassed that story, in that little video. So now that capability is out there, you're starting to run away from the bullet designs that exist. So that spire point design it's not designed to shoot a deer at 600 yards. It's not. Is there cartridges that will do it with that? Yes, absolutely. But generally speaking, that's not what it was intended for. The SST, that's not necessarily what it was intended for. That's a traditional range hunting bullet at the time of its design. Awesome bullet. But what we're seeing is that limit is continuing to be pushed. And so that's where you see the evolution get into like the ELDX, where we had to go back to the drawing board and say, hey, these guys are taking shots that are outside of the design criteria for spire point, for SST, for GMX. We have to develop something new from the ground up to give them the tool that they need to do the job they're trying to do by pushing these limits. So I guess that would be a roundabout way of answering your question, Ryan, of, well, how did we get to where we are? Well, there's a natural process to it when you look back historically. So did that answer your question?
Yeah. Do you see shooters in general putting a precedence on BC, even if they're not going to be in those extended distances or profile?
Absolutely.
Yeah.
All too often, I see an end user making what I would call an on-paper analysis about what he needs to do, and generally it's such a targeted focus on like one or two metrics that they're losing the forest for the trees would be the analogy there. So yes, high BC is good. Generally speaking, nothing else considered, high BC is better than low BC, but that's not the only thing. There's so many different things that you should consider that are not just BC driven. But yes, we are in a world, and I think it's because that long range craze has made its way into so many different facets of shooting and hunting and just the popular culture aspect of it, that BC or drag is so tightly held as a value in that world that it just naturally bleeds off into these other categories, and it doesn't need to do that necessarily.
And I imagine that's one of the slipperiest parts, because now you as a ballistician have to create a projectile that absolutely is going to perform at those extended distances as intended, but then also perform at probably the more realistic distances. So enter bullets like the ELDX. We're taking BC characteristics and profiles of like the older, legacy AMAX, and then you're ramping up the capability of that projectile to hold together under shorter distances when that impact velocity is going to be quite a bit higher, and it would otherwise fragment something else.
Yeah, that's a really good point, that even though the limits are being pushed and we're trying to design things to be used for those new limits that are being pushed, that doesn't mean you get to ignore the legacy needs.
Yeah.
You have to do both. And the more you push those two apart, the further you push past limitation, keeping your anchor in the old legacy ways, the harder it becomes to design something that'll work on both ends of those spectrums.
Right.
Because there's always trade-off. There's nothing for free.
Right.
I mean, we see the exact same thing with optics, and Jaden, you talking about these technologies developing over time, and increasing our effective range because of bullet technology or optics technology. The one thing that we always look back to, and I just think it's at least as one major catalyst, is the rangefinder, right? Is having, because now you do have that known distance in field conditions nearly instantly, right? And that's just such a core piece of information that you need to have all these other things, fall into play. You're able to, utilize the performance of all those other different tools, and to what you guys are talking about, kind of, quotation mark that one bullet to do it all, because you do have these tools. And you may want to utilize them, and you may, have an accurate rifle, and you've gone through the process of getting your ballistic data, and you've practiced, and you've taken all these steps to extend your effective range. But oftentimes you don't need to. Like I use that. I'm like, okay, that's a tool in my toolbox.
Yep.
I hope to shoot this deer at 20 yards.
Yeah.
But I might shoot this deer at 600 yards. And I think a good example, well, really any hunting scenario that can happen, but, I find myself oftentimes I'll be hunting blacktails in western Washington, Ryan, where the last blacktail I shot at 80 yards in the timber, but I was also in that same week potentially going to shoot a deer, like I said, at 600 yards across a canyon over it, into an open clear cut. So that's where it does become tricky to identify, because your capabilities are so
on paper
broad.
anyway.
Yeah,
absolutely. And that's why I think discussions like this are super important, understanding the mechanisms or the triggers rather that have to occur to ensure an ethical kill, right? Like, how does that animal die? And there's a lot more to that question than, well, it's just hypoxia. Well, it's more than that, right? How does that bullet work to make that animal die? And that's why I think these are such valuable, conversations that folks really should kind of pay attention to, and pair up the right projectile to the hunt. Like I shoot monolithic bullets. With that, I understand that I have a minimum velocity that I can expect reliable expansion at, and that's where I draw my line in the sand. Whereas the inverse of that is if you have a bullet designed for very low velocity expansion, either intentionally or just by happenstance, maybe you don't want to be using it for hunting whitetails elk or large, thick-skinned game at tight quarters. You might have a catastrophic failure that you hadn't intended on, but we've got to match the projectile, what it was designed for, for those distances for that game. So don't go hunt elk with your VMAX, I guess,
Right.
or any varmint bullet, but lightning on the prairie dog town for sure.
For sure, and I think Jayden made a really good point there. It's like you're picking. You may be selecting or inclined to select a bullet on paper. You're like, it's got this BC, it's got this velocity, or maybe it's a cartridge say it's got this velocity, it's got this, and this. You might need that, and maybe something that has, a lower BC or whatever. Those variable change. Likely the optimal bullet for how you are going to be using it. If you're in the whitetail woods of Wisconsin, and a long shot could be 200 yards on the property that you're hunting, consider these things and pick the appropriate bullet.
Yep, absolutely. Mm-hmm. No, that's how I got into reloading. I picked the inappropriate bullet. But truly, I think I wasn't in an inadequate caliber. It was a 243, and I think it's a fine deer cartridge. But I picked the wrong bullet because the 16-year-old version of me got into reading some of these gun regs and started listening to rapid expansion and maximum energy transfer, and I left it at that. Like, I didn't go deeper into the study to figure out exactly what rapid expansion and maximum energy transfer meant. Picked the wrong bullet and made a poor shot, like it was a hilarious Rube Goldberg machine of failures. And then I said, okay, well, there's got to be a better solution to this. And that's what kicked me off into serious centerfire reloading is that.
Yeah. I mean, I guess, I have a similar story to that of picking a bullet on paper way back in the day. It was like the first monolithic. It's like, oh my gosh, this bullet is so tough and it's going to drive and, whatever. And then I shot a deer at 60 or 80 yards with it. And the deer kind of ran over, and I made a pretty good shot, hunched up a little bit, and I was like, kind of like it didn't tip over. Boom.
Wait a minute.
Shot it again. It ran into some thick stuff. Unfortunately, a couple hours later, I find it, but it still had its head up.
Yeah.
And just I didn't have the right bullet for the job.
Yeah. Yeah. Yeah, super important. And I mean, with anything, the right tool for the job. I often state that, like, when folks are looking at high magnification rifle scopes with very technical reticles and technical turrets, and the intent is hunting, say, Midwestern game. This is like driving a Ferrari for your daily driver when you're in city traffic. Super cool car, goes really fast. Not friendly to drive necessarily in that setting, but match the tool for the job, I think, is a huge takeaway.
Well, that's something we have to design too. So even though, as you said, Mark, even though that ELDX will expand at velocities well beyond any other bullet we have, it still has to work at the close range stuff. So it really depends on defining the environment and the job you're trying to do. So if I'm up with you guys in Wisconsin and we're hunting deer and the furthest shot is 200, I can take my pick. I can use any one of the bullets in our lineup, minus varmint, right? It's got to be the correct application. But I could do Spire Point, SST, CX, or ELDX. Mm-hmm. All of them will work just fine. If, let's say, Ryan, back to your point, do I want to find that bullet on the offside hide on the other side of the shoulder? Or do I want an entrance and an exit wound to help with blood trail, or have air coming in 2 holes instead of 1? Whatever those old adages are that you want to prescribe to, none of them are all right or all wrong. They all have validity, but I can pick any one of those. But if we're meeting up in Wyoming to go on an elk hunt, I'm not going to, and let's say I'm trained and capable to take that 600-yard shot that we said, I'm not going to use the Spire Point for that application because it doesn't have the drag characteristics I need to make sure that I have enough velocity at 600 for it to work. That's going to drive me down to that ELDX application, right? So it really depends on, the first thing to define is, what job are you trying to do? What's the animal? What are the ranges you're trying to do it at? And more importantly than the ranges, what are the retained velocity ranges that you're looking at? Because it's those two tied together. It's not just range. What you really need to look for is velocity. Like you said, I need to figure out what is the minimum velocity this bullet's designed to work with. And Ryan, just like you said, okay, there's my range line in the sand that I'm not going to go beyond, because then the bullet won't work.
Yep.
Yeah, I mean, you might be getting reliable impacts
Sure.
beyond that range.
Yeah.
Sure.
But it doesn't mean the bullet's going to perform
potentially
how it's intended.
Yeah.
Right.
Yeah. That's the great mystery. Can you make me a bullet that controls expansion at hypervelocity and then also at like 1,000 feet per second? that'd be really cool.
There's a funny story there on ELDX. So when we set out to design the ELDX, which for the listeners, the ELDX is kind of an all-range hunting bullet. It's the first bullet that we've been able to design where it will work at 30 yards and down to 1,600 feet per second.
Yeah.
So you're talking like 800 yards plus with most of the modern cartridges environment, depending. But what we saw happening in that evolution of the all the equipment and everything, long range capabilities, people are pushing their limits, is that guys were using bullets. They were going for BC, Ryan, just like you said.
Yep.
They said, I'm shooting long range. I need high BC to do that effectively. That's like their criteria number one. Sure, okay, that's not wrong. Well, what was out there at that time? Bowtail hollow points that were really sleek in design was the majority of that. There was tip to match bullets too, but what a lot of guys were doing was shooting animals with those bowtail hollow point designs. Those bullets don't expand. Although hollow point is in the name and there is a little hollow point in them, that's not a big enough hollow point to allow enough hydrostatic media inside for it to open, like the way a pistol jacketed hollow point does. But that's got a giant gaping hollow cavity in the front, right? So what happens with those bowtail hollow points, and it doesn't matter who makes them. We make bowtail hollow points, Burgers here. It doesn't matter who makes it. It's a function of the bullet design. That bullet's not designed to expand. That bullet is designed to shoot very accurately on paper and steel targets. That was its original design purpose, right? So what happens when you shoot an animal with that is that bullet does not expand. At best, it will tumble or yaw. So what happens is the bullet comes into the animal, it hits enough resistance based on whatever it hits, let's say ribs or shoulder or just muscle tissue or skin tissue. If it meets enough resistance to cause the bullet to start to go end over end, now the bullet's going sideways and it's increased its surface area, so your energy dissipation is better than if it just stayed point forward, right? The problem with that is it's all a function of things that you can't control.
Right.
It's a function of the twist rate of your barrel, ultimately the spin rate of the bullet on impact, which is going to define its gyroscopic stability, the target media of the animal. Did you hit it on a rib bone or in between the ribs where there's cartilage or on muscle tissue? All of those have different densities, meaning they're all going to cause the bullet to yaw or not at a different time or distance perspective from penetration. And then third is the angle of the attack of the bullet at the point of impact. All three of those things you can't control. So the terminal performance is out of your control. And so the guys that were using all those were struggling. They would shoot one animal and it would drop dead in its tracks. And same circumstance, they'd shoot another one, the bullet would pencil through, they'd see dust kick up behind it, and they lose the animal. It runs off for miles, An elk can go a long ways wounded. So we set out to design a better tool. And when we did that, we had designed a bullet that was awesome. I mean, it would hold together at short range, and it was expanding down to velocities that were like approaching 1,000, 1,200 yards. I mean, this thing was awesome. That was when we got our Doppler radar, and we're drag testing these bullets, and there was something wrong. Marketing was ready to launch the product. All those guys had their information; they were ready to go. And we came back from a long range radar trip and said, "Pump the brakes, guys! We got to stop. There's something wrong." That resulted in the discovery of what is now heat shield tip. So the aerodynamic deformation of some of those older legacy polymer tip designs of different bullet manufacturers. But anyway, to your point, like we thought we had it nailed and like the ultimate one-all bullet, right? Like doesn't matter what range you shoot it at, works the same every time, But what became the ELDX is really, really close to that.
Yeah. No, what I think is always cool is anytime I get a new rig or I rebarrel something or whatever, it's like if it shoots ELDX, we're good. Okay.
Yeah.
And so like my first foray into it is always with that ammo and like, does it print? Okay, I at least know I'm good there. Now I can go experiment with different flavors and see if I can make something that I think is super cool or whatever. But if it shoots ELDX, it's like, okay, cool. Baseline of performance has been established. We're safe.
Right.
Yeah.
Right.
Yeah.
Hey, Jaden, you were talking about the Doppler and what was happening to that bullet as it passed through the air. So what did you guys discover that led to that heat shield tip?
Well, when we went out to do that long-range Doppler test, what we were doing was trying to gather the final BC numbers for marketing. That was the last piece of info they needed to launch the product publicly. and the numbers we were seeing did not add up. I mean, because you can take a bullet just based on its shape and make some estimates on what the BC should be, and it'll be pretty close within an acceptable margin of error. But we want fine-tuned exact numbers, you know. Mm-hmm. So we had made the estimated numbers based on the shape, and then when we went out and tested it, it was nowhere near that. And some of the behavior that we saw in the drag curves was very abnormal. It did not look right. It did not look like it should based on the shape of that bullet. Long story short, I mean, a ton of testing and research and experimentation, we figured out that the type of polymers used back then and are still used by some manufacturers today, the bullet gets hot enough when you shoot it through the barrel, right? There's some friction that's occurring, and you have, you know, very hot gases behind it propelling it down the barrel. The bullet gets very hot from that, but also in flight, as that bullet is breaking the sound barrier, there's some heat associated with that. And the heat that was occurring between firing the bullet, the heat generated by the shock wave of it breaking the speed of sound, and also by environmental temperature, so meaning it would be worse on a 90-degree day than it would be on a 30-degree day, was causing the polymer material at that time of those tips to deform a little bit. And that deformation, that the ogive and the point of that bullet is really critical and plays into the overall drag characteristics quite heavily. It's very influential. And that was causing a degrading of the BC, higher drag, right? So what we figured out was that classification of polymer would not withstand that level of heat, and we went to a different class that would, and that's what you see now is the heat shield tip. So that tip is able to withstand all of the heat associated with firing and travel downrange.
Would that be something that you would notice less at maybe a shorter distance, but because of the time of flight, it starts to extrapolate over time?
Mm-hmm. Yeah, it's nonlinear, so it gets worse as time goes on. So you're exactly right. It is present at 100, 200, 300 yards, but you're talking such a, your absolute numbers. Let's say it's a fixed percentage. Let's say it's a 5%, just to throw some number out there. Well, 5% of 1 inch is a whole lot different than 5% of 100 inches, which it would be at 1,000 because it's nonlinear, right? As time goes, as the time of flight increases, those things become more and more nonlinear. Fascinating.
It is.
We've talked a lot about the ELDX here, but I find that bullet, interesting. What's special about that bullet that does make it, versatile for those, I guess close in shots to further out shots?
We had to go back to the drawing board on the way a bullet expands. So kind of back to some of the initial stuff we talked about in this conversation. So expansion and penetration are opposing metrics. And what I mean by that is if you want really, really long or deep penetration, you can't have a ton of expansion because as the bullet expands more, it gets more of a surface area. It's going to slow down faster and it's going to come to a stop at a shorter distance. Your penetration is less. So there's a trade-off there. What we needed to do was make a bullet that was heavily designed enough that you could shoot it at 30 yards and it can withstand that high velocity impact and expand in a controlled manner, but be soft enough that at 800 yards it could do the exact same thing. Well, those are two opposing jobs. Because if I build it hard enough to withstand the high velocity stuff, by the time it gets to the low velocity, it barely expands anymore at all, if not at all. So now I have super deep penetration, but no expansion. My energy transfer into the animal is no good. So we changed the way that bullets expand. And what I mean by that is generally, if you look at a wound cavity, or you could go look at ballistics gel images that do a good job of showing that, what you'll see is as the bullet enters the animal and it starts to expand, you see like a tapering, almost like a ballooning effect of the cavity, the temporary cavity of the energy transfer, and then it tapers itself back off, kind of a up and then back, right? What we did with the ELDX is we figured out a way to control the jacket flow on expansion in a way that we took that, what would be a balloon, let's say a volleyball-sized balloon, we took that and we took that same area that would take up of temporary cavity and we stretched it longer, meaning we made it not as tall, a little bit less tall, but longer. And so by doing that, you're taking up the same volume of You're depositing the same energy from a volume of wound channel standpoint, but you're lengthening it out. And in doing that, we could control the high velocity impact and the low velocity impact. It was pretty cool. We had never done that with a bullet design before. It was always kind of the old traditional, bullets hit and they open up to their max diameter, and then, the wound channel tapers off as the velocity's lost till they stop, and that is what it is. But this was a kind of a smart design bullet.
Which brings me to a great question, or maybe a statement. You can't necessarily just model this, right? And then like blow air at the tip of the bullet and make it expand and then get an idea of this. You guys have to shoot these things into different media, and a lot of them. And a lot of testing. That must take the development cycle on that must just be awesome.
Yes, it can be either awesome or extremely frustrating, depending on how the testing comes out.
Yeah.
Yes, when we're designing a bullet for terminal, there is a ton of testing that's done in ballistics gelatin.
Yep.
10% ordnance gelatin to be specific. There's a lot of that clear ballistics gel stuff that's out there. It's not the same thing, and it's not representative.
Interesting.
Yes, you have to have 10% ordnance gelatin, because what that is it's essentially a pig byproduct material through processing that is dehydrated and ground into a powder. So you have a mixture of bone, cartilage, organ tissue, muscle tissue, kind of everything, right? Anything that's not going to be used or is a scrap. You take that powder, you hydrate it with a certain ratio of water, which we are, 70% water is the common term, and then that sets up in a material that is a very similar density to your average of a body. So if you average the density of bone, cartilage, organ tissue, muscle tissue, all that stuff, you would get what 10% ordnance gelatin is. What you have with that clear ballistic stuff is it's more of like a fishing lure type material. It's synthetic. And so it's missing the moisture content that the ballistics gelatin is. So what happens is when you test a bullet in that, you don't transmit the energy in the same way because there's not moisture in that material. So although it's an attractive test medium, because you can take that clear ballistics gel and set it on the table and it's not going to rot. If I take a block of 10% ordnance gelatin and I set it on this table for a day, it's going to get nasty. It's going to decompose and stink, and just it's worse to deal with, but it's substantially more accurate on the results you're getting. So we start with the 10% ordnance gelatin. We'll do a ton of testing there. After we're happy with that, then we go test. We go hunt, and we cut animals open, and we see what stuff looks what it looks like. And I would say the 10% ordnance gelatin is probably 90% of the prediction of what will happen in an animal. It's extremely similar.
Yeah, that's cool.
Can you, with the ordnance gelatin, can you see into it, or do you have to physically, like, what can you tell from the outside, or do you have to get into it and recover the bullet before you can tell what happened?
No, you can absolutely see into it.
You can.
Yes. So if, like on our website, I know we have a bunch of pictures of that, especially like if you go to the ELDX specific page, or there's a white paper that we wrote on that page, and that's got a ton of information in it. But yes, the ballistics gelatin's like a kind of like a goldish yellow color that's fairly translucent. You can see through it, especially if you backlight it or put lights underneath it. A lot of it depends on how you make it. If you make it bad, it will be really cloudy and it's hard to see through. But if you make it in the correct way, it's very, very easy to see through. We do also cut them open, to get measurements on the inside. But you can take measurements from the outside as well.
Mm-hmm. Mm-hmm. What about, you look at like how and maybe it varies or there's an average, but like how long does that? How long is okay, you want to recover the bullet, right? Yeah. Mm-hmm. Oftentimes on game, like, a deer is only so many inches wide, right? Mm-hmm. So oftentimes you don't recover the bullet, so you don't really know what happened. Like, I guess I'm not asking this correctly, but like you might be looking at to capture the bullet with its energy and everything, it has to go maybe further than the average diameter of, say, a deer or something like that. So then you're evaluating something that's happened after it's already potentially left the animal.
Mm-hmm. So you can make some numbers to that. So when we're testing in like research and development stuff, let's say this is an elk bullet. Well, we're going to make sure we have enough gelatin that it's an elk plus, right? So we can catch that. So we may have, 40 inches of gelatin depth that we're shooting into to make sure we catch it. But just from an animal, you can sort of make some associations just based on the wound characteristics after you start to process that animal. You can see how far, so you have your permanent wound cavity. That's the material that the bullet physically displaced by its presence, right? That's the material that had to get out of the way of the bullet moving through it. Then you have the temporary cavity. The temporary cavity is that transfer of energy from the bullet to tissue areas outside of that permanent cavity. That's what we see in the ballistics gel very easily. Well, in an animal, you can still see that. As you cut into that animal, you can see fissures or tears in the tissue that are way over here. When the bullet came through, right for the heart shot, you have blood bruising and tearing of the outside of the lung tissue way over here on the side. That would give you an indication of, yes, the temporary cavitation effect reached that level. So you could kind of make some assumptions and correlations between what happened in the animal and what happened in the ballistics gelatin.
Yeah, for sure. Because you're still seeing that, that essentially that temporary, wound cavity in the ballistics gel too. So you could say, okay, from inch 1 through 40, like here's the entry. Here's what would be the midpoint of the animal. Essentially, here's where it likely may have exited, and you can see what's happened throughout its journey. Ryan.
Right. And that temporary cavity is really important because what you should think of the temporary cavity of is your error box. So because we don't all make perfect shots, although, we say we do. I'm going to take a shot at the heart and I might miss. I misjudged the wind and I ended up hitting, 4 inches right of the heart. So physically, my bullet's never going to touch the heart. But depending on how that bullet is designed to produce the temporary wound cavity, if that temporary wound cavity encompasses the heart, I may still have my desired effect of shutting that pump down. So your temporary cavity, especially the diameter of that, but also the depth and how it's laid out, really tells you how bad you can screw up as the shooter and still have the effect that you're going for. So that's a really important thing when you think about the wound characteristics of a bullet, is that allows me to know how much can I screw up and still have the job done the way I want it.
Mm-hmm. And some of that, what you're talking about, I'd say that kind of contrasts with how, like, we kill things with arrows still today, right? Mm-hmm. Killing a little bit differently, though, yes?
Yes. Yeah, so I'm no expert on arrows by any means, but an arrow kills by cutting, not by necessarily energy transfer that we've been talking about with a bullet, because an arrow doesn't have the energy. It has the weight, right? Arrows are quite heavy compared to a bullet. You're talking probably 400 to 600 grains for an arrow would be a decent average, where bullets we're talking probably 100 to 200 grains for the majority of hunting bullets used in different calibers. The advantage that the bullet has is the velocity, because part of that energy calculation is velocity, and velocity gets squared. So your velocity is a big player in how much energy there's going to be there. So with the arrow, it's more of a cutting and a sectional density benefit. So the sectional density usually correlates to the penetration. So you've probably seen, if you've experienced it, an arrow is going to penetrate a lot deeper than a bullet will. And I know there's some good videos and stuff I've seen on the internet that demonstrate that in a way that a lot of times surprises people, because they think, well, an arrow is only going, 200-300 feet per second maybe. That's not very fast. And yeah, it weighs 600 grains, but 200 feet per second is a whole lot slower than 3,000 feet per second, So they affect the animal in different ways, but I'm by no means an expert on the arrow stuff.
What about possibly a similar relationship there? Like, we talk about, the variables or attributes that we're looking at as far as, like, okay, you got a heavy bullet versus maybe a lighter bullet that's going faster. Mm-hmm. What could a person be looking at, when trying to analyze those things?
So generally, let's say of the same bullet design.
Yes.
Right? As you increase velocity, generally you're going to increase expansion. As you increase expansion, you reduce penetration. Now, on the flip side of that, heavier bullet, probably going to be going slower, right? Because it's heavier. Let's say it's in the same cartridge, so it will be going slower. Mm-hmm. Slower velocity means less expansion. less expansion means more penetration. So that's mass not considered. That's how those two things play. So now when you throw bullet mass into it, that 200 grain bullet is going to penetrate deeper because it's heavier, just by default. That's back to the arrow, right? The arrow having that sectional density that makes it penetrate so deep. So from a selection standpoint, you really need to define what is the vital depth of the animal I'm trying to shoot, because the vitals depth on a deer is a lot less than the vitals depth on an elk, which is a lot different than the Cape buffalo, right? So remember the priority is shot placement first, penetration second. So I need to make sure that what I'm selecting is going to penetrate deep enough that I can physically touch those vital organs. If the lighter weight bullet will do that and the heavier weight bullet will do that, then you can start to assess things on different levels. Do I value recoil in this situation? If so, maybe I want to go with the lighter bullet. If it shoots the same level of accuracy and all those other metrics you're concerned with, if it'll do the same job, maybe I want to go with the lighter bullet because it will do everything I need it to do for this hunt, and I don't have to deal with crazy recoil. And I mean, from an ego perspective, yeah, sure, I have a giant Magnum with the heaviest bullet around, and I can,
yes,
I can suffer that recoil and not wince at all. But from a reality perspective, like we started this podcast with, sometimes you shoot a deer and it drops in its tracks, and sometimes you shoot a deer and it runs off and you have to follow up, just like you were saying on that one hunt, Mark. Recoil is a big player in that. If my recoil is so obnoxious and my rifle is so lightweight that after I touch a round off, I lose all sight of what's going on, if I have to make a follow-up shot, I'm going to be much less likely to be successful in that with that super heavy recoiling system than I am with a lighter, faster weight, or a faster, lighter weight system, if that makes sense.
Yeah, no, it makes perfect sense. And I guess, another thing to think about is shot angle too. We don't always get that broadside shot, so you may need to consider okay, like you're talking about, hey, you want to reach those vitals. Well, how much of that animal does that bullet need to pass through to reach the vitals? And then have I selected the bullet that's going to perform good enough to do so?
Absolutely. Or the backwards limit of that would be, I'm going with this system, and I know that it has X penetration depth. The only real shots I can take are broadside shots. Because if this animal turns frontal, like this bullet isn't built heavy enough to be able to make it through that brisket area and still get deep enough to the vitals, let's say on an elk, right? So because that's a big difference, the broadside shot on an elk versus a frontal shot or a frontal quartered shot or whatever. So then you may be able to say, well, I'm using this system because it meets all my criteria, but I have to limit myself from the perspective of the animal's orientation. Like I can't take a front quartered shot on this animal. I have to wait till it's full broadside. That would be another way to look at it.
Yeah, for sure.
Those caveats are super important to think about.
Yeah, there's just so many things at play when you're hunting and you're in the woods. And I don't know about you guys, but I've never had two identical situations.
No,
not 100%.
I've had a lot of stuff that was like by script. This should have been absolutely toast, and 2 inches of error meant something wildly different. But one of my best whitetails I killed at 32 yards, double lunged, and good on the lungs too, not like back. Low velocity application. Didn't hit enough bone or anything else to displace that bullet and open it up. And I had a full pass through, and I recovered him 193 yards later. Yeah. And like by textbook, hit him right in the vitals. Well, I was 2 inches high of like the pericardium, and it would have been just a signed, sealed, and delivered deal there. He didn't bleed for like 80, 90 yards. And then
that's a great example of those timelines associated. We assume that it's kind of like in the movies you see some bad guy get shot in the movies and he goes flying back against the wall and he's dead immediately. Well, that same thing kind of exists in hunting. We assume, hunting is you go out with a rifle and you shoot an animal and it dies and it's over. But that's not the case at all. No. There's so much more nuance to it than that.
Yeah.
And this might vary too. How long does it take to design a bullet? And this is just curiosity. How long are you guys working on a bullet before it hits the shelves?
Depends on the job it's trying to do and how hard that job is going to be to kind of crack the nut on. It could be as quick as a week. If you consider everything though, so let's say you're designing something brand new. You don't have anything pre-existing that you can kind of rob off of. Let's say, you know, because that would be, oh, we have this tooling that's already made for this bullet over here, and we can use that same tooling for this new bullet because it has so much similarities, that crossover. You know, that would save you a lot. But when you're talking about like from scratch, ground up, I mean, the timelines to get the tooling made and designed to where you can make the bullet. And then let's say it's a hunting bullet or something that has a terminal performance requirement, law enforcement, military, hunting, something like that. Well, we're going to make our first stab at it. We're going to have all this tooling made based on the dimensions we think things need to be at to get this bullet to work. Then we're going to make the bullet, and then we're going to test it. And we're going to find out, oh, wait, we need to tweak this one and this one and this one from a tooling perspective. Well, now you start that timeline over again. You're going to go back, remake all that tooling. Then you come back in, make the bullet again, and you test it again. And you say, oh, well, you know, we made it halfway to where we want to be from where we were, but we still got some room to go. So you do that again, and then you come back and you test that, and you find out, oh, we changed things so much in that regard that it ended up affecting this thing over here that wasn't even associated with what we were first looking at. Well, now we got to fix that. So there's a lot of that goes on. A really complex bullet like the ELDX, that bullet took months just on the terminal performance part of it. So it can be anywhere from a super easy bullet. You know, let's say you're going to make a competition pistol bullet for like USPSA or something, right? Pretty simple bullet. You want it to be lower cost so that it's affordable for high volume shooting, stuff like that. That one's pretty easy. That's not too hard because you're going to rob off of existing designs and knowledge that's already been, you know, that groundwork's already been laid. You're kind of just adapting it to this new thing. But when you're talking from the ground up, it can be a challenge for sure.
Can I ask about the CX without taking another 3 hours? Because I want so many questions.
Well, no, that was actually going to be likely my next one, and that's like a personal question asking for a friend. I'm curious about it because I've shot the GMX, its predecessor, a lot, and saw. In fact, actually, I was like, oh, I need to order some GMXs. I'm like, well, there's no more GMXs.
Yeah.
So what's Ryan? Yes, please.
Oh, well, so this was exciting for me because I am a copper shooter, and when I saw the announcement, and again, I kind of have to talk out of both sides of my mouth. Like, I'm not obsessed with BC personally because maybe it's just because that's where my comfort level is at about 500-600 yard range, and I'm not necessarily realizing a lot of the benefits that these uber high BC projectiles have, or maybe it's a condition of I've shot homogeneous bullets with characteristically low BCs for a long time, and I'm just accustomed to it now. But when I saw that bullet announced and I looked at it and I saw the BC figures, the first thing in my head I thought was, oh my gosh, I can now potentially extend that distance. Potentially, not that I'm necessarily gonna, but when I saw those figures, I thought, like, wow, this is quite honestly probably the best copper design on the market or homogeneous design on the market, because it's still a gilding metal alloy, is it not? Okay,
it is.
Cool.
That's correct.
So yeah, like, what was the ethos, the theory, and what are your thoughts on the projectile for somebody like me?
Sure.
Yeah.
It kind of fits back into that conversation about the evolution in bullets that we've seen. Yeah. You know, that evolution made a beeline towards ELDX, but at the same time, there's jobs that ELDX won't do that those copper or monolithic designs will. One of those is the lead-free option. Yep. Right? That's a big one. Another one is you can build those bullets in a way that they will expand and penetrate more deep than you can with a traditional cup and core, just because that material is so hard. So if you take one of the new CXs, let's use a big Magnum like a 300 PRC with a 190 CX and then a 212 ELDX. That 190 CX is going to penetrate deeper than that 212 ELDX will. And that's just a function of that monolithic type design I was talking about earlier. So what led us to go down the road that became the CX? You obviously, we've seen this limit pushing of range and capability, and we designed the ELDX to cover that. But we've learned a lot over the years, and we took a look at the GMX and said, well, why is this way? Why is that way? Other manufacturers' bullets of the same category, same thing. Well, why is this way and that way? There wasn't a good answer for some of it. And so we started doing some experimentation, because you're rather limited with that monolithic design because it's all one material. You can't really do much on the inside. You can't make it heavier or lighter, really, you're really limited from a stability standpoint on how far you can go weight-wise with those bullets. So we took a hard look at the new groove geometry that you probably saw on those, and we did a bunch of experimentation and found a geometry that reduced the drag, which was really cool because traditionally you had that old kind of like square style of groove or cantilever that you see on our old legacy GMX as well as other manufacturer stuff. And the question was, why are those that way? And there wasn't really a good answer. Now, those grooves serve very obvious purposes, but the reason that they were that specific way, there wasn't a good answer for it. So we started messing around. I mean, most of our products are from messing around. A lot of them are because we're all shooters and hunters around here, and so I want something that does this, and well, there's nothing there yet, so I'm gonna just go mess around with something and see if I can get it to do it, and then take that down the hallway to Jason and Steve Hornady and say, hey boss, I was messing around and this happened, and they're like, oh, right on, let's do it. That's kind of how it works. So the groove geometry was a big one that really lowered the drag in a way that it kept the other criteria. So when you have those monolithic bullets, they're very hard, and they don't have much give to them. So when a bullet engraves itself into the rifling of the barrel, there's some give that occurs, especially with a cup and core bullet. It has almost like a sponginess, you could view it as. Those solid bullets don't have that. I mean, they're just a solid, hard material, so they don't give very well. So you have to have grooves on there so that as the bullet engraves into the rifling, there's bullet material that's displaced by the rifling where it kind of engraves its way into the sides. And you have to give that material that's displaced a place to go. Otherwise, you'll see an increase in pressure due to that. And so that's one of the purposes of those grooves. The other purpose is to give you a location to crimp the case mouth into. That's not a requirement. Obviously, we make a lot of bullets that don't have a cantilever, and they work just fine. But that is an option there. So looking at that groove geometry, we made some discoveries there and implemented that on the CX. That increased the BCs, or lowered the drag, to a point where it was now applicable to use the heat shield tip. So the old legacy GMX never had a heat shield tip because it wasn't applicable. So that whole heat shield tip discovery, there was a threshold, and that threshold was essentially if your G1 BC was above 0.5 and your muzzle velocity was above 2,600 feet per second, you could see tip deformation with the old stuff. You wouldn't see it if it didn't meet those categories. So a varmint bullet, say a 55 grain VMAX out of a 22-250, velocity is way past 2,600 feet per second. So you're meeting that category, but the BC is way less than 0.5 for the G1. The tip doesn't melt because it slows down so rapidly because the BC is so low. Even though the velocity is high enough to generate those temperatures to deform the tip, it loses that velocity so fast. As you lose the velocity, you lose the heat. Nothing ever happens. The GMX fit into that category. None of those bullets were of high enough BC to justify the benefit of the heat shield tip. When we did those the changes to the grooves, that increased the BC enough that now it would benefit from the heat shield tip. So we heat shield tipped all of them. That increased it even more again yet. So that's why, Ryan, you notice such a big jump in the aerodynamics of the CX versus the GMX. And what that means is you can now, like you said, I could shoot these at longer distances if I wanted to. Yeah. Because the BC is higher, I retain velocity better. So I've taken my bottom end expansion window for velocity and I've pushed it down range a little bit. The other way you could view it, to your point, I may not shoot those at longer distances. I may keep them in the traditional ranges I've always used them. You're going to hit with more energy now because you're retaining more velocity. So you get a twofold benefit. If you want to push your limits a little bit more, you can. If you don't want to, you're just hitting that animal with more energy.
Yep. No, I was very excited, and I think after you had mentioned this, like it wasn't a radical profile change to like the shape of the bullet necessarily. It was just minor tweaks that actually made very substantial and big differences. So It's not like there's this huge departure from convention in that bullet's profile and shape. It's just intelligent design changes that yielded very tangible results. So I'm excited. Mark, now that you don't have any GMXs left or you're getting dangerously low, I think we should go buy some CXs and we should load 300 Wisdom. I was loading 300 Wisdom last night.
Oh, really?
Right here.
Should have called me.
Well.
That was awesome. That was awesome. Ryan, and yes, I do get, before I ask my last question, Jaden, have we missed anything along the way with our questions? Which I can't think of anything.
No, I think, I hope that it's been a useful conversation for the listeners. Definitely the topics we covered could each be rabbit holes themselves that we really get into the nitty gritty on. But I know, we wanted to cover some ground in this podcast, and I think we did a good job of that.
I know it's been incredibly enlightening for myself, and the crazy thing is like, I know we haven't gotten into that nitty gritty, but we've covered a lot of nitty gritty.
Oh yeah.
So that's been pretty cool.
Yeah.
Ryan, do you have anything else?
I'm still kind of big fanboy situation over here.
I'm
trying to contain myself. We could write books.
They have.
I have them. I have them.
With all this, so I'm gonna wrap it here.
Yeah.
I don't want to, but I am.
Yeah.
With all this like just crazy development and improvement and just like amazing bullet technology that we've seen, develop over time. What do you see as next? Like, it just seems like stuff's so good right now. Like, is there aside from laser beams, maybe that's it. Maybe you guys are working on that. I don't know.
No, because that would ruin everything.
Yeah, I agree.
You're right.
Where do we go next?
I mean, somehow you guys keep doing it. Like, seems like every year it's like, interesting. It's better. I thought it was already the best.
One of the coolest things about this field that I've found is I've never gotten, and not me personally that I'm anything to speak on, but I think in the field itself, we haven't gotten to the bottom of it yet. We make a big discovery, say heat shield tip. We get done with heat shield tip. Man, that's pretty awesome. That's a pretty cool discovery, and look how much it benefited the product, and this is great. And then 5 years later, here comes A-tip.
Yeah.
So what is after that? I know what we're working on right now that I can't speak of, but I think you'll continue to see improvements, and it may be the small percentage areas that we lack. We've really maximized a lot of different categories. You guys on optics are covering that. There's you guys are in the same boat, right? Mm-hmm. There's how much left to be desired is there? There's still some. There's some little things that we could try to do here or here. And a lot of times what we find is that prior limitations, you kind of have to reassess everything all the time. Because, let's say 5 years ago, we couldn't do this because of X limitation. Let's say it was a tooling limitation or a machine limitation or something. It says you can dream that up all day long, but you can't do it. The way technology is advancing, that limit may no longer be valid 2 years after that. And so you kind of have to constantly reassess. Like, it's a balance between where's the holes, where's the problems that we think we could improve upon, and how do those fit into what our capabilities are. And it's just this constant state because the capabilities are changing so quickly that what you thought was impossible yesterday is completely possible today, So do I think we go to laser beams? No, because that ruins everything.
Correct.
And, I mean, I'm a huge fan of a brass cartridge case with a traditional primer, with traditional smokeless propellant, launching a Freedom seed down a steel tube. I think that's cool. But when you look at that, we've been doing that for a long time. Not much has changed there. That's all the same stuff. So you see technology coming out in like the new cartridge case design type stuff, the polymer cases and all that kind of stuff. I don't think that technology is there yet in a way that it can confront the elephant in the room that is the current technology and its proven track record for over 100 years now. Right? The new technology comes and it's super cool and shiny, but it's prone to breaking and it's prone to failure, and we don't fully understand its limits. It hasn't had 100 years to flesh it out, right? But we do have that with what we're using now. And so I think you'll continue to see this technology that we've been using for 100 years in the brass cartridge case and all those traditional components I talked about. You'll continue to see those get advanced in those last little 3-4% advantages that exist here and here and here. You'll continue to see that. And I think at the same time, you'll probably see a branch continuing to, go off into the horizon of these new technologies and how to implement them. But I don't think they will eliminate the validity of the old ways. I don't think we're there yet.
Mm-hmm. Mm-hmm.
Did that answer it?
That's
a
perfect.
Tough question, Mark.
Bullets and cartridges, they're like the ocean. we're just,
we don't even know what's out there yet.
We're just,
Yeah.
exactly. We got new technology. We're always finding new stuff.
Yeah. If it is crazy to think about. I mean, 6.5 Creedmoor came out in 2007, and look at what it's changed the entire industry. That cartridge alone, and then the way that we shoot things, the way that we think about things, the way that we build scopes, the way that rifle manufacturers build rifles. Like something small like that is such a huge potential to be a catalyst for remarkable change.
Mm-hmm.
I know every year at SHOT Show, I'm so excited. What is going to be behind the big red H?
Yeah.
Well, and we've talked about this, but we're talking about like the technology and capabilities is kind of fluid, so you have to like reevaluate. But that's also like happened because of those same things. It's like I reevaluate like what I'm capable of, right?
Yeah.
When I started hunting, 300 yards, that was a poke.
Yeah.
Now you reevaluate. Like, well, now that isn't my limitation now. So I don't know. All super cool stuff. Like I said before, Jaden. Number one, appreciate the time and incredibly enlightening conversation, tons of great explanation. I know I learned a lot, and I think hopefully the listeners out there, learned a lot about bullets and cartridges today, because that was cool.
Yes. Very.
Well, I appreciate you guys having me on. It was a great conversation. I had a blast. If we need to do another one, just let us know.
I think we could probably dive into some additional specifics. So let's plan on that for sure.
Cool. We didn't even touch internal or external ballistics, so there's plenty to go into.
Now we've done it. We've opened the ballistics can of worms, if you will. But awesome. Well, thanks for the time. I guess everybody stay tuned for the next one, and we'll catch you on the next one. Thanks everybody for listening.
See ya.
Bye.
There you have it, folks. Thank you very much for listening. As usual, give this video a like if you liked it, comment something below, and give us a subscribe to the Vortex Nation podcast channel. It would mean a lot to us. Also, why don't you give us a follow over on Instagram while you're at it, at Vortex Nation Podcast. We'd love to hear from you over there, and we'll keep you updated with all kinds of cool photos and videos from our adventures that we do here. Otherwise, we will see you on the next one. Thank you again. Happy hunting and shooting, everybody. Have a good one.